This will be a lesson over some multiple choice AP questions for Chapter 4. These are going to be difficult questions that were taken from previous AP exams, so consider the material here a little tougher than what we did in class. Let's get to it. Number 1, we have a 0.10 molar aqueous solution of sodium sulfate, and it's a better conductor of electricity than the same molarity solution of sodium chloride. Which of the following best explains the observation? Now, remember, a better conductor of electricity simply means there are more ions dissolved in solution. Whenever you have ions in solution, that's when the substance can conduct electricity. And so, let's see which answer makes best sense. A says that Na2SO4 is more soluble than NaCl. This is not true. Both of these have sodium, and all sodium compounds, all group 1 metal compounds, are completely soluble. That one's out. B says sodium sulfate has a higher molar mass. This is true, but this doesn't explain why it's a better conductor. So that one is out. Molar mass doesn't really have much to do with conductivity. It's ions that have to do with conductivity. To prepare a given volume of 0.10 molar solution, the mass of sodium sulfate needed is more than twice the mass of NaCl needed. This is also true, again, because sodium sulfate just has a higher molar mass. There are more atoms in sodium sulfate. But this doesn't explain the conductivity. Now, D is the correct answer, but let me go through E to discuss why E is not, and then we'll come back to D. The degree of dissociation of Na2SO4 is significantly greater than that of NaCl. Now, the degree of dissociation says that, or tries to say that sodium sulfate breaks apart more. In truth, both of these break apart the same amount in terms of they both completely break apart. Sodium sulfate completely breaks apart into sodium and sulfate 2-. In other words, there is not any that stay together. And same thing with sodium chloride, they completely break apart. So this idea of dissociation, acids will dissociate partially, weak acids will, strong acids will dissociate completely. But in this case, they both dissociate completely. And that way, that is not the best answer. D is correct because more ions are present in sodium sulfate than there are in sodium chloride. In fact, for every sodium sulfate that dissociates, you get twice as many ions of sodium because of this little tube. And essentially, you have more ions in solution, you have greater conductivity. Let's try the second one. In the second one, we have a 0.20 mole sample of magnesium chloride and a 0.10 mole sample of potassium chloride are dissolved and diluted to 500 mils. What is the concentration of chloride in the solution? Now, what we need to see here, kind of like in the previous example, is that every magnesium chloride gives you 2 Cl minuses when it dissociates. Every KCl gives you only 1 Cl minus when it dissociates. So from the 2 mole sample, we actually get 4 moles of chloride. So we have 0.40 moles of Cl minus from here, again, because it doubles as it dissociates. One way of thinking about this, you can say, is your magnesium chloride, you can write an equation showing it to dissociate into magnesium 2 plus and 2 Cl minuses. This is where you would see it. And so KCl just gives us 0.10. So we got 0.10 moles of Cl minus from there for a total of 0.50 moles. So what's the concentration of Cl minus in solution? Now, the concentration, remember, is molarity. Molarity is moles over liter, so we still have to divide by this liter. So essentially, you're dividing by half a liter because 500 milliliters is 0.5 of a liter. So you're dividing 0.5 by 0.5. Now, dividing by 0.5 is the same thing as dividing by a half. Anytime you divide by a half, you're multiplying by 2. So the answer here is 1.0 molar. Hopefully that made sense. And so we have E as the answer here. Let's go on to number 3. In number 3, we have, let's pull all of the rest up. We have when a student prepares an aqueous solution containing 5 cations, we have silver, mercury, copper, manganese, and barium. And what do you do to a dead chemist? Barium. And so the student observes that no precipitate forms. which of the following could be the identity of the anion? Remember, the anion is the negative ion in the solution. And really what we're looking for is which of these anions will have no exception to solubility. And if you recall that chloride has the robbers as the exceptions, and the robbers are actually, two of the robbers are here. The carbonate is generally not soluble, so that one's out. Chromate is generally insoluble. But if you recall that nitrate is the one with no exceptions. So nitrate is the correct. Sulfate also had exceptions, if you recall. So that nitrate, this one's a quick one, nitrate would be the right answer. How about the next one? A 1 liter sample of an aqueous solution contains 0.10 mole of sodium chloride and 0.10 mole of calcium chloride. What is the minimum number of moles of silver nitrate that must be added to the solution in order to precipitate all the chloride as silver chloride? What we're saying here is that when you react silver nitrate with chloride, you get a precipitate. And the reaction is silver plus chloride gives you AgCl. This would be the net ionic equation for the solution, or for the reaction. So what we've got here is we have, looks like kind of like in the previous example, we have 0.10 moles of sodium chloride producing 0.10 moles of chloride, because for every 1 sodium chloride you get 1 chloride. In the case of calcium chloride, you get twice as much, again because of this 2. So you end up with 0.20 moles of chloride from this solution. So we have a total of 0.30 moles of chloride to be precipitated. So since silver and chloride are 1-to-1 ratio as they react with one another, you need the same amount of chloride because of stoichiometry. You need the same amount of silver. So for every 1 chloride, we need 1 silver. We have 0.3 moles of chloride, we need 0.3 moles of silver. And that is why C is the right answer. Let's do the last one here on this page. A 20 milliliter sample of 0.2 molar potassium carbonate solution is added to 30 ml sample of 0.4 molar barium nitrate solution. Barium carbonate precipitates, which makes sense because barium carbonate is a solid. It is not soluble. Usually carbonates are not soluble. The concentration of barium ion in the solution after the reaction is. They want us to calculate how much barium 2 plus is left. Now what you see here is you're adding more barium nitrate, notice 30 mils, of a more concentrated solution and less of the potassium carbonate. So we will have barium left over after the solution. That's the idea. This is going to be a tough one. This is the toughest definitely of the 5 here. So let's first find out, because whenever these react, they react in moles. Again, you can write the reaction as barium 2 plus reacting with carbonate 2 minus, giving you barium carbonate. So it's literally 1 mole of this for 1 mole of this reacting to give you 1 mole of our precipitate. Now, let's find out how many moles we have of each substance, because again, moles are what are reacting. The way to do this is to use molarity. Remember that molarity is moles over liter. So to solve for moles, moles will give us molarity times liters. So essentially we're going to multiply both our molarity and the liters to find out how many moles of each we have. Let's do that here. We have 20 milliliters. Again, 20 milliliters is the same thing as 0.020 liters. And we'll multiply that by 0.2 molar times 0.200 molar. And you can say 0.2 with a big M at the back. And this should give us, now if you use a calculator, you'd find yourself, you should get yourself 0.004, if I'm not mistaken. Let me show you how to do this without a calculator. This is actually an important thing to be able to do for the AP exam. Eventually, they don't let you use a calculator for the multiple choice section. So let me show you how you would do this without a calculator. What you want to do is you want to rewrite these numbers like this. If I switch over this number twice to the right, And if I switch over this number once to the right, I've done this twice, I've done this once, I've done it 3 times total. I've moved the decimal place 3 times to the right. And now I have 2 essentially times 2. Now I can do 2 times 2. That gives me 4. And then my answer, I'll have to move 3 decimal places back to the left. So watch this. 1, 2, 3. Put the zeros in, and your answer here is 0.004 moles. Hopefully you saw how I did that. This is a trick, a math trick that will get you the answer quicker. So we have 0.004 moles of potassium carbonate. If we just do the same thing to the barium nitrate, and since we're kind of running out of room, let me do it up here for barium nitrate. We have 0.030 times 0.400. If we do the same trick, we essentially end up doing twice here, once here. We end up doing 3 times 4, which is 12. And then we have to move 12 back 3 decimal places. 1, 2, 3. We get 0.012. So we have 0.012 moles of our barium nitrate. So this is our second number. So what we're doing in our reaction, and it looks a bit messy, let me rewrite it down here. We have barium 2+ reacting with carbonate in a precipitation reaction to give you barium carbonate. We're beginning with 0.004 moles of the carbonate. So we have 0.004 here. We're beginning with 0.012 moles of the barium. So 0.012 moles here. Now, whenever this happens, what we have is we see that we have an excess of barium. We have too much barium. So all of the carbonate will precipitate out, and we will have left 0.008 moles. Think about that for a minute, but essentially 0.004 of barium will completely precipitate 0.004 of carbonate to form barium carbonate. So because we have this much left over in the solution, they want the concentration. They say the concentration of barium ions. So we have to now divide this by liters, because again, concentration is in molarity, which is moles per liter. So the way to do this is divide by the liters. Well, how many liters do we divide by? Let's see how much we've added. We added 20 milliliters of our original solution with 30 milliliters of the other solution. So we added a total of 50 milliliters. 50 mils is 0.050 liters. So we really end up dividing our moles that are left over by 0.05. Now, to do this without a calculator, if you divide by 0.5, you're effectively multiplying by 2. So if you divide by 0.05, you're effectively multiplying by 20. So really, because if I say that 0.5 is 1/2, 0.05 is 1/20. So we're going to multiply by 20. Eventually what you're doing is you're doing 0.008 times 20. And you can do the same thing. You can swing it 1, 2, 3 times to the right. So you end up doing 8 times 20. 8 times 20 is 160. And then we moved it 3 times to the right, move it 3 times to the left, 3, and get 0.160 for the answer. And here is 0.160. This was a confusing one, most likely. Think through it again. Logic it out on your own. Double check the math. And the math is, I'm going to do this a lot with these questions, as you're not allowed to use a calculator, but there is a way to get the answer without a calculator. So hopefully you've enjoyed this. We're going to do another video of the other 2 questions.